Okay, so we're going into Chapter 8. We're starting to study quadrilaterals now. And we're looking at 8.1 today. And in 8.1, we're looking at finding the angle measures in polygons. This is something that you have studied before back in your pre-algebra days, 7th, 8th grade, measures in polygons. So first, we have a definition. Diagonal of a polygon. And this is a segment that joins two non-consecutive vertices. Section 8.1. So diagonal of a polygon. This is a segment that joins two non-consecutive vertices. So here, BD is a diagonal, BE is a diagonal, AD would be a diagonal, AC is a diagonal, CE is a diagonal. Yes, it does. Okay, so all of those are diagonals for this polygon. Okay, theorem 8.1. Polygon interior angles. It says the sum of the measures of the interior angles of a convex polygon is n minus 2 times 180. Good question. N-gon, or n, in this theorem, n represents the number of sides or the number of angles, depending on how you want to look at it. N is the number of sides. So, for example, why it says n-gon here is if it were 6, it would be a hexagon. If it were 5, it would be pentagon. If it were 19, it would be 19agon. Remembering labeling these polygons from Chapter 1. Yes, Molly? Yes, n minus 2 times 180, yeah. Now, one thing to remember here is that this is the sum of the measures of the interior angles, the sum of them. So whatever you get with this formula, that's all the angles being added together. Now, another key word in here is convex. What does the word convex mean? What does convex mean? This kicks us back to Chapter 1 again also. What does the word convex mean, Lauren? All exterior vertices, very good, yes. So, if I were to look at a convex polygon compared to, what's the other type of polygon? We have convex and concave. Convex polygon look like that. And then a convex polygon, concave, so this is convex. And concave, you have a vertex on the interior of the polygon. So convex and concave. This theorem only works for those polygons that are convex. So n minus 2 times 180. So for example, if we had a 10-sided shape, a decagon, our n would be 10. We would do 10 minus 2, which is 8, times 180. And that would be the sum of all of the angles of a convex decagon. When I add up all the angles, this theorem will give us that sum. Okay, a corollary to this theorem is that the sum of the measures of the interior angles of a quadrilateral is 180 degrees. Now, once again, that has to be a convex quadrilateral. So looking at example 1. Find the sum of the measures of the interior angles of a convex octagon. How many sides does an octagon have, Kellen? 8. So our n is 8. We use the theorem n minus 2 times 180. Substitute 8 in for n. 8 minus 2 times 180. That's 6 times 180. 6 times 180, that's 1,080 degrees. Okay, looking at example 2. Example 2 says the sum of the measures of the interior angles of a convex polygon is 1,260 degrees. Classify the polygon by the number of sides. So, what do you have to find in this one? What is it that you're trying to find, Brendan? The number of sides. So we're trying to find n. And Pierce, what do they give you? Okay, so we know that the sum of the measure of all the angles is 1260. So we have 1260. And now how do we solve for the number of sides? What do we have to set that equal to? Molly. Sorry, what? What do we set this equal to in order to find the number of sides? Nicole. Very good. So what are you setting it equal to? Yes, you did it correct. Alexis. Yeah, n minus 2 times 180. We're making an equation here. So we're going to set it equal to n minus 2 times 180. Now, Nicole, what's the first step in solving for n? Good, we could divide by 180. Divide both sides by 180. And we get n minus 2 equals whatever 1260 divided by 180 is. What is it? 7. Add 2 to each side, so n equals 9. What type of polygon do we have, Andy? A nonagon, very good. Keep in mind, once you get up to like 13 sides, 14 sides, we just call it like 14-agon, 15-gon. Okay. Okay, your assignment for tonight, coming out of this pink packet. (8.1b). 8.1b, numbers 1 to 15. 8.1b, numbers 1 to 15.